Now that we have learned about the tools and we've learned about scaling, we're going to progress into creating geometric shapes, some basic geometric shapes, and learn how to scale at the same time, learn how to construct your basic geometric shapes. We'll take a page, a sheet 8.5 by 11 of vellum, as we did with our first exercise with the line work exercises. And we'll divide it up into about 6 different basic shapes that we'll learn how to construct. So we'll take our sheet and do our borders as we do. And the easiest way to do that is tape your sheet down about the middle of your table as you're measuring a 1/2 inch border all around. This now gives us our basic bordered sheet. And then we want to have a spot for our little title that we'll have. So we want to divide this into 6 equal blocks. So obviously left to right, 1, 2, 3, 4, 5, 6. We can divide this right in half. And if this was a 8.5 by 11 sheet, we can see that this distance we could divide right in half. You can do it by measurement or you can do it graphically. One way is measuring it. Obviously, 8.5 minus 1/2 is 7.5. Half of 7.5 is 3 3/4. And then it can draw your dividing line right up. Okay. Now we want to divide vertically into 3 blocks. So now we want to find a number between this line, the bottom line, and the top line that'll divide by 3. I could measure it and say, well, I have about 9.5 inches left. So what's 1/3 of 9.5? But that's an irregular number. So here, graphically, works out better. So we're going to find some number that divides by 3 on our scale. And a number that divides by 3 pretty easy would be 12. And since we have room on our drawing to put 0 on the bottom and 12 on the top, I can then mark off every 4 inches. So 4, 8, and 12 will give me 3 equal boxes. So I've made those marks. They should be in the 3rd spots. I'll draw my horizontal blocks. First geometric shape we'll be drawing will be intersecting circles. And we'll want each of these objects to be relatively centered. So one way to establish the center of an area is very lightly draw diagonals, right, from each of the corners, and that will establish the center of the box. Just very light, just so it doesn't read, because you're going to want your object to read, but you're going to want to know where your center is. So we're going to try to create an intersecting circle. A rough sketch might be something like this. So now we have our center. We're going to draw the horizontal center line. And since we know that our circles are 5/8 of an inch in diameter, in radius, inch and 10, we're going to have our center, vertical center, be split by 5/8 of an inch as well. So that's the construction for the center lines. The intersection of the circles, 5/8 of an inch, centered on the block, 5/16 on the right, 5/16 on the left. Another 5/8 for the radius of the circle, and then another 5/8 for the radius of the right circle. So you'll see altogether you're going to be 1 inch, 1 1/4, 1 1/2, 1 3/4, 1 7/8. So we'll try the compass method. So we'll take the point of the bow compass and we'll put that in the center, and we'll put the pencil, the lead point, we'll screw that down to where it hits the mark that we've set off. and see that we're 5/8. And we'll just rotate it lightly, just a gentle drawing, and it should hit the other side to make a 5/8 inch circle. And if you were to measure and draw what the dimensions of this are, you would see that you have like your center line here with 5/16 drawn on either side of the center for the overlap of the circles, and that the circles themselves make up about 1 7/8 inches altogether. Dimension line for the over. You could also show an actual radius here and a radius here. Where the center is a radius of 5/8 inches. You can draw some. You can draw some guidelines to remind you the radius is 5/8 of an inch. This radius is also 5/8 of an inch. You could draw the center of the circle with the intersection sign, which will probably not be so easy to see because it actually is where the lines of the circles are. But that would give you the sign. Dimensions, a little hash mark for the overall, 1 7/8 inches. A little dimension for the overlap. And since it's a center line, we tend to draw a little dot for the center line. And then we'll call that line CL, center line. And then we'll say, we measure this, about 1/8 inch high letters, that each offset is 5/16 of an inch. And if we want to give that a title, using 1/8 inch high letters, we might line up our lettering with the end of the object that we've drawn. We'll call that, its Latin name, Vesca Piscis. Let's take the next shape that's obvious, and we'll go into the triangle. We'll draw an equilateral triangle. We'll try to center that in the box as well. So we'll again create our center line. Since we have the center from here, we could just draw that center line right across from the one we've already established. And where that intersects the block right here, that would be the center line. Basically, the height of an equilateral triangle would be the height. The base would be half of the height because it's cut in half, with the hypotenuse being one of the legs that we know. It's the 24-foot side. So since it's a 24-foot base and 24-foot hypotenuse, the formula would be a squared plus b squared equals c squared. We know c squared is 24. We know b squared is half of the hypotenuse, or 12 feet. We just don't know the height because that's the straight line. So it's basically solving for h. H becomes 8 squared plus h divided by half squared equals 24 squared. Solving for h, you get h is 24 squared minus 12 squared, or the square root of 452. If you use your calculator, you get about 20.18 inches, which is 20 feet, 9 inches for the height. So all you have to do is measure half up and half down, and we'll be at the center. So let's take half of 20 feet 9, and since we're doing it at 16th scale, that's 10 feet, 4.5. So here's 8 feet, 10 feet. That's 6, just shy of 6, just shy of half. So it should be about this. 20 feet, 9, so there is 16, 20, 21, and then 29, just short of that. So we'll mark that off. That should be about the center now. And we'll create the baseline. Okay, so there's the baseline at about half of that when it's done. And it's also 24 feet. So we'll draw 12 feet from the center line, which is here, and 12 feet on the other side. So we shall take our scale on the base, put it at 12 feet, go to 0 to the right, and 12 feet plus 12 is 24. That's 16, 20, 24 there on the left. We've marked off our center line in our baseline from the center in scale. So what you do to create an equilateral triangle is set your compass on one side of the base, spread it to the other side where it's 24 feet, and just mark off that point. Strike an arc that crosses the vertical bisector there, like that. Now you'll turn it around and put your compass point on the other side of the line, drawn to the same width to where you started, cross over, and they will intersect at the vertical bisector. And we can connect these points now and emphasize more of our equilateral triangle right there. Heavy up the line a little bit. Again, flip it over this way, and you get the shape from, again, 60 degrees this way. Draw that line and connect the base. And there's your equilateral triangle, centered in the square. So if you were to take each of these arcs in here, this angle inside here, 60 degrees. This angle inside here, 60 degrees. And the top angle also, 60 degrees. So that every angle in an equilateral triangle is adding up to 180 degrees. So there are a lot of properties to the equilateral triangle that will be useful in design creation to understand how to construct that. So that's 60 degrees. This is 60 degrees. And this is 60 degrees.